Okay, so now we're going to start using similar triangles in real life problems or real world scenarios. So the first picture I would like for you to try to draw, even if it looks something like this, with a little stick figure, and then something like that with a tree. Of course, use your straight edge though to make the triangles. And because the person is standing straight up and down, this is going to be a 90-degree angle here, and the tree is going to be perpendicular to the ground as well. And then it shows us that these two angles are the same. So what we have here are similar triangles, one formed by a person and his shadow, and the other formed by a tree and its shadow. So after you've drawn the picture, label that the person is 5 foot tall. The shadow, the length of his shadow will be 3.2 feet tall, and the length of the tree shadow will be 25 feet long, not tall. And the question that I'd like for you to answer would be, how tall is the tree? So because these triangles that have been formed are similar by the angle-angle postulate, we can set up a proportion. So if we call the height of the tree x, then we're just, again, matching corresponding parts to set up our proportion. So the height of the person, 5 feet, over the height of the tree, we don't know yet, we'll call that x, is going to equal the person's shadow, 3.25, over the tree shadow, 25. Alright, so go ahead and pause the video and see if you get what I get after cross multiplying. Okay, so you should have gotten that the tree is about 38.5 feet tall. Now because we're using similar triangles, we want our answer to represent the height of the tree. So we wouldn't just put x equals 38.5. We're going to write out an answer about how tall the tree is. Okay, the next example, if you just want to draw the triangles, you don't have to draw all this background, and write down this information. A surveyor made this sketch from measurements he made along a river. So this is the river back here, encompassing A to T. So let's go ahead and answer the question, what is the distance across the river? So from A to T. So again, we have similar triangles because these two angles are vertical and angle A and D are right angles. So by the angle-angle postulate, we do have similar triangles. I'm going to call AT x. That's the distance across the river. And I'd like for you to set up a proportion and solve for x, the distance across the river. Pause the video and see if you get what I get. Okay, and you should have gotten that A to T is 60 feet. If you didn't get it, raise your hand and I will be happy to explain why. Okay, so when you draw this next example, we're going to say you can just draw like a stick figure, and you want him to look like he's looking downwards. And this part will represent his height, which is 6 foot. This represents how far away he is standing from, this is going to be a well. We're going to say this is a well. He's looking down a well. And as he looks down, we see that this distance across the well is 6 foot. And the question I want you to answer is, how deep is the well? So this length right here, which would also be the same as this length here. So if you see the two triangles, one here, Alright, so now I'd like for you to pause the video, set up a proportion to solve for x, or the height of the well, or how deep the well is, and see if you get what I get. Well, first on the left hand corner, let's go ahead and write how deep is the well. Okay, pause the video and see if you get what I get. And you should get that the well is 18 feet deep. Now I purposely didn't show my work because I want you to show yours and to try it completely on your own. If you didn't get 18 feet deep, raise your hand and we'll be happy to help you. Okay, and the last example we're going to do without a picture. The information we're given is that a boy knows that his height is 6 feet tall. At that time of day, when his shadow is 4 feet, a tree shadow is 24 feet. Go ahead and write down this example. So pause the video, write down the example. And the question I want answered is, how tall is the tree? So anytime you have a word problem where we're talking about people's heights and shadows, the reason that they form similar triangles, and the reason we're going to set up similar triangles, is because if you have a shadow at the same time of day, they're going to be proportional based on whatever the object's height is. So let's break this down. A boy knows that his height is 6 feet. So let's go ahead and draw a boy. He is 6 feet. At the time of day when his shadow is 4 feet. Now a shadow, this is the part that a lot of you will miss. You'll draw the shadow like this, but that's not the shadow. Your shadow is on the ground. So his shadow is 4 feet. Then we have a tree's shadow, which is 24 feet. So let's go ahead and draw a tree. Here's my wonderful tree again. Don't be jealous of my awesome art skills. So the tree, we don't know how tall the tree is. So if we're trying to figure out the height of the tree, and both the human, here's a right angle, and the tree, here's a right angle, are going to be perpendicular to the ground. The way that the sun hits the tree and the person is what makes this end up being a triangle, where this angle has to be the same for both figures because the way that the sun is beaming down on them. So because of angle, we have two similar triangles. So now we'll use that information to find the height of the tree. So if we know that the boy's shadow is 4 foot, it's going to be compared to 24 foot of the tree's shadow. And that's going to equal the boy's height over the tree's height because they're going to be proportionate. So we cross multiply and we get 4x equals 6 times 24, which equals 144. And then we would divide both sides by 4. So we get that the x is 36. And remember, this answer represents the height of the tree. So we want to say that the tree is 36 foot tall. And that would be your final answer. Alright, now you're going to use what you've learned to take your exit quiz. It is called Exit Quiz Using Similar Triangles.